Okay, we're continuing with grade 11 and 12, as well as grade 10 final exam revision for analytical geometry. This is question number 3, which reads as follows. Show that the triangle joining the vertices A, B, and C is an isosceles triangle. Okay, so I'm just going to bring up a shape there, and then we've got that, and we've got the B there, and we've got C over there as follows. Show that this is an isosceles triangle. Okay, so if I need to remind you as to what an isosceles triangle looks like, it's a triangle more or less like the one you see here, where um, for example, this is length 3, and this is length 3, and this is length 5. Then I can say that that's isosceles because there are two sides that are equal in length. Now, if I want to prove that a triangle is isosceles, and need I remind you that equilateral triangles are also isosceles triangles, because to be an isosceles triangle we need at least two sides of the triangle to be equivalent, right? So now I need to say, for example, let's work out what is the length if this was A and this was if this was A over there and this was B over here and this was C over here, then I can conclude if AB is equal to AC, the triangle is therefore isosceles, right? Now in coordinate geometry, the point that we make here is that these triangles are isosceles if two of their lengths are equal. Now to find the length of a line or a side of a triangle, we need to use something called the distance formula. So let's start off by doing it for AB, which will be the one side of the triangle, BC will be the other side, and AC will be the third side. So let's take it for, let's get a red pen going there. Let's do AB first. AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now what does that give us? Well, let's take the b's to be our set of 2's. So I'm going to say, and let's work with the y's, with the x's first, I'm going to say minus 7 minus minus 4 and square that, and then I'm going to take the y's and I'm going to say 4 minus 8 and square that over there. Now what does this give us? Well, minus 7 plus 4 is minus 3, and minus 3, if I square that, I'm going to get positive 9, and then 4 minus 8 is minus 4 squared is going to be positive 16. Okay, and that's going to give me the following. That's going to say, well, okay, that's actually the square root of 25, and the square root of 25 is just 5. And there we go. That's the length of AB. Now let's do it for BC. Let's see what happens with BC. Well, again, BC is equal to the square root of, let's make it the x's first, minus 8 minus 7, right? Plus, let's work with the y's. It's going to be 11 minus 4 squared. And remember, your order needs to be consistent. We need to say minus 8 minus 7 and then 11 minus 4. And what does that give us? Well, that's going to give us the following. It's going to say, well, minus 8 plus 7 is minus 1. Minus 1 squared is just positive 1. And 11 minus 4 is going to be 7. And 7 squared is going to be 49. Plus 49. Plus 49, right? So this is going to give us the square root of 50. Okay, so that is equal to the square root of 50. Now clearly the square root of 25 is not the same as the square root of 50, and I'm not going to bother to further simplify that over there. In fact, this is actually 5 root 2. But let's stop there and let's see. AB is equal to 5, BC is equal to root 50, AB is equal to 5, and BC, oops, let's just do that a little bit neater, and then BC is equal to root 50. And so let's see what is in stock now, in store for us over here from AC. Well, if I have to work out AC, I can say that AC is equal to the square root of the C minus A, which is going to be minus 8 minus minus 4, and let's square that, plus 11 minus 8 and square that over there. So what do I get? I get the following. I get Minus 8 plus 4 is going to be minus 4, and square that I'm going to get 16. And then I'm going to say 11 minus 8, and that gives me 3. So 3 squared is going to be positive 9. And so now I can see that, well, that is actually root 25, and root 25 is just 5. So now clearly I can see that AB and AC are equivalent. And because these two sides are equivalent, AC and AB, I can conclude, therefore, triangle ABC is isosceles. Okay, and that concludes question number 3.